Hello and welcome back. In this video, we are going to talk about the math. As we saw earlier, realize now that there's a lot of classes, all right, classes that come with Java language that we can use in our own project. That way we don't have to recreate everything from scratch, okay? There's this one class called math class, and as you may guess, math class deals with a lot of math functions. So here it is in our Java library, in our Java class library here. So I went ahead and found this math class, and you can see it has fields, but not many, but it has a lot of methods. Now, one thing that you will notice right away is that all these methods have this static type. What does that mean? Well, if we go back and start thinking about when we create classes, we are creating entities, right? And then if we want to use those entities, those classes, we instantiate them, meaning we say, for instance, person, my persons equals new person. Then now we have my person as the instance of the person object. And then we can say person, my person dot something, and we can access attributes and methods of that class. Okay. However, if we start thinking about utility classes, which are classes that don't necessarily need to be instantiated, because if we instantiate classes, we are using memory, right? So if we don't need to instantiate classes to do whatever we want to do, that's when we want to make sure that those methods inside of that class are static. What does that mean? For instance, if all we want to do is find the abstract value of -45, it would be a waste of time and resources if we had to say math equals new math, because all we need to do is accessing this absolute value method. That's why we have it static, which essentially says does not depend on instance variables at all. There's no need to instantiate that class in order to use their methods. Let me show you exactly what I mean by that. If we wanted to, for instance, let's have an int here, call it my value, and give it -45. Okay, and if we want to get the absolute value of -45, we would have to say math, right, equal new math. You notice we have a problem. It's starting to show us very different classes that we are not even sure about at this point. Well, one of the reasons is because we know that all we need here is actually get the absolute value of -45. We don't have to instantiate math class. So math class in this case has methods that are static, which means we don't have to instantiate the math class in order to use those methods. All we have to do literally is just say math dot, and you see we have all of these methods we can use. So ABS stands for absolute value, right? All of these different functions that we can use, different methods that we can use. Okay, so in this case we can say ABS, enter, and we pass my value. And then we would have, of course, our absolute value. Let's print this out. So say, save this and run. We should see 45 because -45 absolute value is indeed 45. Let's see if we add another number here into second value, 56. What if we wanted to say system out print, let's say minimum of these two values, my value and second value? Well, we can do the same here. We can say math dot min. There's minimum there we can pass, and we can say my value, and the second number will be, we can just say your second value. Okay, you can save this, give it a run. Let's go like this here so that doesn't run both of them. Run again, -45. So the minimum between these two numbers is obviously -45. The point I'm trying to emphasize here is that the math class here, in fact, if you hover over, you will see there's a lot of information here you can read on your own time. But the math class is what we call a utility class, which means we just use it to access those methods, static methods. Therefore, the math class doesn't require us to instantiate the class in order for us to use its static methods. And if you say, why is this so important? Well, because in this case, in the math.min, the instance variable does not affect the behavior. Meaning that my value and second value, if we keep doing the same thing, passing in different values, it will always yield to the same conclusion, which is the value, the minimum between these two values here. Okay? Which is different from any other class that it's not a utility class. Okay? For instance, if you create a class called person, and that person class has instance variables, those instance variables do change the behavior of the entire class. Okay, so let's do something like this. Int x, we can go ahead equal math.min, my value, and then second value. This is the same thing I'm doing here. I'm just gonna organize things a little bit. Say int y, math.absolute value of my value. Okay. Let's go ahead here and system out all of that. Xmin, so x, let's get rid of this. Essentially, it's all the same thing. I just want to organize things a little bit better here. Going back to emphasize what's really happening here, you notice that these values here, so if we run this, we're going to have -45 and 45. Okay, so min, ABS, and many other methods of math class, they don't use instance variables. So their state is not dependent on the instance variables. Therefore, we don't need to instantiate the math class in order to access these methods. Does that make sense? Because of that, it will be really silly to have to instantiate the math class in order to use these main absolute value methods. So this goes back to the idea that whenever you are creating your own classes, try to figure out if the class that you are creating, if its methods need to be static or non-static. If the instance variables of that class are not needed inside of the methods of that class, then you probably have a utility class, which means the class should have static methods, such as the math class. And you notice, in order to access those, you don't have to instantiate anything. All you have to do is say math dot and then access the method that you want and pass in the values and you get a result. That's simple. Now let's play around a little bit here. Let's say if we created an instance variable to our static project class here, say private string name, okay? And then we said, for instance, here, and then we create a method here. Let's say public set name, and we're gonna pass string and public void. Okay, there we go. And then here we can say then name. Just setting things up here is equal to n, as in name here, okay? Okay, so what are we doing here? Let's go ahead and comment this all out. So we went ahead and created an instance variable called name. You know, it's here in our static project, and then we created a setter, right? So we're setting the instance variable here to whatever we're getting in set name, okay? We could, inside of our static void main method here, notice it's static. If we went ahead and said, for instance, system.out, and we want to print out the name, if we say name, where is the name? It's not showing. It's not even showing inside of a static. Well, it turns out in order for us to access instance variables inside of a static method, we will have to have a static instance variable as well. So if we went ahead and say static here, look what's going to happen. There we go. Now, inside of our static void main method, we are able to access the name variable, instance variable. That means if you want to use instance variables inside of our static methods, well, that instance variable has to also be static, because static doesn't really care much about instance variables. So only if that instance variable is also static, then I say, okay, I get it. You are static. I'm also static. So we can actually talk. Okay. Same thing here. If we wanted to access this set name here inside of our static method, if we said, for instance, set static project dot set, the moment we say static project dot, the only thing we can see that is visible inside of our static void here is name and other things that we don't care much about right now, right? We cannot see our set name. So if we want to go ahead and access this set name here, let's say we can go ahead and instantiate our class. We can go ahead and say my state project, my project is equal to new project. And now we can go ahead and say my project dot name. Okay, the string name static here, it's showing, right? Our instance variable is showing. Let's go ahead. If we say system.out.println and we say set name, it's nowhere to be found. Well, because set name is not static. But the moment we say static, but we can say set name, and there it is, set name. Of course, if we were to actually call set name, we're gonna have an error because it's the wrong way to call it. But you can see now the visibility, what we can see inside of our static method here versus what we can't see inside of our static method. So the moral of the story here, if you want to call anything inside of a static method, in this case, the main static method here, it better also be static. Okay, so if you want to call an instance variable, well, it has to be static. If you want to call a setter or a getter or a method outside, it also has to be a static method. So everything has to be static in order for things to work when it comes to static methods. So in this video, I just wanted to show you a little bit of the static type. You know, what is static type and why we use static types and how to use them and when to use them and when not to use them, when it makes sense to use them and when it doesn't make no sense to use them. Okay, so that's a very important concept to understand, because as we've been talking about in the Java library, there are a lot of classes. I mean, thousands and thousands of classes, right? And some of classes you will find as you continue your journey with Java, you will see a lot of these different types of classes. So it's important to start thinking and understanding what they all mean, all of those types, right? Static and so forth. All right, without going any further here, we'll stop here. And if this makes no sense, please ask questions. If something's not really clicking, just go back and rewatch this video. And if you still have other questions, just ask and I'll be here to help you, okay? All right, so I'll see you in the next video.